Hey everybody, this is Unit 11, Area and Volume Solids. This is concept number 2, surface area, lateral surface area and volumes. Ice cream cones. Who can ever turn away the beautiful look of a nice ice cream cone? That's a lot of ice cream there. Let's go ahead and get started. Before we get too far into this, I want to suggest that you go down into the description box just underneath this video and click on the link and download the video notes. That will have the pictures that you're going to experience in this video, and it'll allow you, instead of having to draw them, you'll just be able to print up the document. It'll have the pictures there waiting for you, and you'll just write your notes onto those papers, and then you can either staple it or tape it into your video notebook. Also, the other thing, and this is the geometry SOL formula sheet. And so this formula sheet is also included in those notes. But if you're not going to print that up, at some point I would suggest that you go to Google and Google that form. And so have this at your hand so that you can take a look at what's going to be provided formula-wise on the SOL, so you can see what things you need to memorize and not have to memorize as you're working through this section. All right, we're going to look at some of these figures here, and we're going to make sure that you understand the difference between height and slant height. So when we're looking at the height of these solids that we have in this picture here, they obviously a cylinder is a little bit different than the other ones. The one at the top here is a prism, as well as that pentagonal thing. That's a prism, pentagonal prism. We have to be able to look at these shapes and identify what are the bases of them. Don't make the mistake to think that this is the base. That's just plain silly, and I've never talked about it that way. The base of this shape is these two triangles. And the reason I know it's a prism is because rectangles connect those things together. Now the distance between them is given here as 10, or 11, I'm sorry. That's the height, okay, of this prism. It doesn't matter if it's laying down like this or if it's standing straight up and down. The height of the cylinder is the distance between the two bases, once again. So in this case, the height is the sides. It doesn't matter if this cylinder is laying on its side, right? The height is still the distance between the two bases, measured as a perpendicular. The height over here on this pentagon prism, once again, the distance between the two bases is given over here on the edge. See if you can take a look at this trapezoidal prism and identify where the height is. Put me on pause, just make a guess, and then come back and check it. Okay, quite often students will identify this is the height of the trapezoid and think that means it's the height of the prism. Don't make that mistake. The height of the prism still is the distance between the two bases. In this case, it's 4. Now the pyramid's height is from its peak straight down to the base. Hey, that's not such a surprise. In this case, the height of this pyramid is 11. Now a new height is introduced here in this pyramid. This height is from here straight down, straight down from the top down to the apothem, as we've talked about in class. That's lowercase a, right? That's the apothem, the distance from the center of the pentagon to an edge. Now this height here is actually called the slant. That's the slant height. Sometimes they use an italics L to represent the slant height. I want to take a few seconds and introduce a new type of figure and a new word. It's called oblique. Whenever you take a shape and you turn it to kind of lean over like that, this becomes an oblique, in this case, an oblique cylinder. And we can do this with prisms. Kind of push them over, it becomes an oblique prism. Now the reason I'm bringing that up is because the height of this cylinder is still measured perpendicular from the base to the other base. That's no big surprise. But I hope that you'd realize the side of the cylinder is no longer the same length. Okay? So this height right here, this length here, guess what it's going to be called? I hope that you just guessed, a slant height. All right, so let's take a look at this prism. And again, this is a triangular prism, and we're going to look at lateral area and surface area, two different concepts but closely related. So let's start with lateral area. Lateral area is the sum of all the sides of this prism. And in this case, all the sides are going to be, all the faces, lateral faces, are going to be called rectangles. Hopefully you can see that. So as you can see, that first rectangle has dimensions of 7.5 and 10. Now in a moment, we're going to unfold that formula that I have up there. Lateral area equals HP. But in the meantime, let's just keep on looking at this. The next rectangle is this one, which has dimensions of 8 and 7.5. And then finally, we have the last rectangle, which has dimensions of 7.5 and 6. So the lateral area is the sum of all the areas, the number of squares it takes to cover each one of these three rectangles. Now I'm hoping that you could do this on your own. This would be 75. And so again, I hope you can find all these on your own. You just multiply length times width to get each of the area. This all tallies up to being 180 units, in this case feet squares. It's the number of squares it takes to cover this shape. Lateral faces, not the entire shape because we're not including the bases. Now if you look at the formula, the height of this is again the distance between the two bases. We've got that. And then let me change its color here so it matches. The height is 7.5, and the perimeter is the distance around your base. Okay, so I just added up those three sides. I stole the 10 and I put it there. And that calculates to be exactly what we had before. Now, when we look at the surface area is the lateral area, which we just found, plus the area of the two bases. So to find the base area, we have to go calculate the area of a triangle. So I love finding the area of right triangles because it's just a matter of using the sides, right? So again, the area of a triangle is 1/2 base times height. And what I can do is use this side, which is perpendicular to this side, and call one base and one the height. When I do that, I get an area for the triangle to be 24. I can just throw that into that formula. 2 times that 24, because that's the area of the base, right? So I throw it in there. I've got myself 228 square feet needed to cover this entire shape. The two top and the bottom, and all the sides. Okay, let's look at this cylinder very quickly. Basically, it's going to be plugging in the numbers, right? And so it makes sense to me that in this equation over here, I would see this 2 pi r h because that's the lateral area. The surface area is going to be the lateral area, which represented by the sides of this big can, right? And then 2 times pi r squared. Pi r squared is the area of a circle. And of course, we have 2 of them. So we're going to have those areas included in the surface area. Okay, put me on pause and do that one on your own. Put the numbers into it. Have fun. And there you have it. And since we're talking area, we'll want to put units on there. I look over here to see the feet or inches, and there's nothing given. When there's nothing given, we'll use the letter U. It stands for units squared. Units squared. Now, if we went and took this and turned it in decimal, if the problem is asking you to round it to the nearest decimal or to the nearest whole, then that makes sense. Go ahead and do that. But if it doesn't say anything, you need to be able to keep it in terms of pi. Let's move on. Okay, so when we take a look at this formula for a lateral area of this, it's just going to help me sum up all the squares it's going to take to cover the triangle lateral faces of this shape. So let's start putting some stuff in here. We got 1/2. L, as we described earlier, is the slant height. So I'm going to need to calculate that one. Now let's just draw our work down here. Exactly like the picture. I've got a height of 11 and I've got a apothem of 8.3. And so I'm going to need to calculate what that is. Go ahead and use Pythagorean theorem. Put me on pause. Come back and check your work. All right, and there you have it. Now, if it's okay with you, I just went ahead and did the square root and rounded it to the nearest decimal. So, lateral height, 13.8. Perimeter, the perimeter is the distance around the base. In this case, we have 5 sides that are 12. That leaves me a 60. I finally calculated it down to 414 square yards. Those are squares with 1 yard by 1 yard it would take to cover all these triangles. Right, there's the surface area formula. Surface area formula is going to be the lateral area plus that base. So let's find the base, the area of the base. Okay, that's a polygon. We're going to use the area equals 1/2 apothem times perimeter. The apothem in this problem goes from the center to the edge, just like we expected to. And this is 8.3. Now, to help us find the perimeter, we're going to need to know an edge. In this case, it's 12. So let's just plug that information in. And I get an area for the base of 249. So now what I'm going to do, I'm going to take this 414, slide it into place. Pull that one out, put that one in that place, pull this one out, throw that in that place, and now I'm going to be able to calculate my surface area. And that's the number of square yards it takes to cover not only the triangles, but the pentagon as well. Now, we don't have much time, and so I'm going to go ahead and skip finding the surface area of that. We've already done prisms up here at the very top with that triangular prism. So the work is going to be the same, just dealing with a different shape. Now, according to our formula sheet, the volume of a prism can be found by taking the base area. In this case, the base is a triangle. It's not because it's at the bottom. That's not what we're talking about. But it is the base. In this case, it is the bottom. That's cool. And then multiplying, so you find the area of that, and then you multiply it times the height. What's happening here is we're finding the area with that big B. We're finding the area of the base. And that's because for every square on the floor of this thing is a cube that can be placed on it. So once I find the area of this, that will tell me how many cubes I can put on the floor. Then when I multiply it by what the height is, that tells me the first layer has so many cubes, every layer after it has that same number of cubes. And I just fill up this object to find its volume. Let's find the area of the triangle. And so I find the area to be 24. So there's 24 squares on the bottom. That means 24 cubes can be placed on the bottom floor of this. And I'm going to multiply that times 7.5 to get the total number of cubes that will go into filling up this prism. I calculate 100, in this case, not feet squares now, cubes. Now when we look at a pyramid, we can find the volume of that. Its formula is a little bit different. It's 1/3 BH. Hopefully you're getting used to what these letters mean, right? So the big B means the area of the base. So we've done that, and if you're not sure how to find the area of that pentagon, you need to go back. You've come this far. You got confused at how I did that, and you kind of kept on going. You don't want to do that. If you go and find the, if we've covered something in the video and you weren't sure what it is, your job is not to continue on, but to rewind it and listen to it until you understand it. So go back and make sure you know how to find the area of a polygon using the apothem formula, right? Okay. All right, so there's our numbers. Now we're just going to plug it into a calculator and do our calculation. And if I did my work right, I have 913 cubic yards. Those are cubes that are 1 yard by 1 yard by 1 yard. Really large cubes, pretty large cubes. It would take to fill this chamber of this pyramid. Now we're going to want to be able to move to shapes like this where they're compound, and so finding its volume, surface area, and things like that. So we're going to have to make sure that we can kind of think through and process that. We don't have time in this video to cover it, but it's pretty easy. If I wanted to do the volume of this thing, I would simply find the volume of that bottom part, which is a prism, and then I'd find the volume of the sphere, and then I would take that volume and cut it in half. This one would be to find the surface area of it, I would find the surface area of the sphere, take half of it. That would give me the top part of this. And then I would add to it the lateral area of the cone. I wouldn't want to use the surface area because the surface area would include this part inside. That's not part of the surface. Okay, well there you have it. These are your do-it problems. I have try it up here again. I'm sorry. These are your do-it problems. Make sure you have the answers to these. Come back next class with them, and you'll be ready to go for some practice in class. Take care.